Hello, I am Tyler Linder. This is my second lab report for Physics 2212 for the summer semester of 2021. And this lab title is Lines of Charge. So to introduce this lab, the purpose of it is to calculate the electric charges on common household objects in a more sophisticated way than the previous lab experiment. We are using GlowScript to create a model of the two charge tapes exerting a force on each other and calculating the amount of charges on each tape necessary to flow over one another. The charges must be distributed evenly across the length of the tape in the model. The fundamental physical properties of this lab include Coulomb's law, Newton's second law, and law of attraction. At the end of this lab, the results came down to the charge of the tape being -5 coulombs times 10 to the 8th, -8th. So the procedure for this experiment is just like lab 1, where we create a base tape and a U-tape and place those on a sticky surface on top of each other, and we remove the U-tape off the base tape really quickly. That charges the U-tape, and then we create another tape as well and do the same thing for that tape. Once those two steps are done, we hover each U-tape over one another and calculate the distance of when they start to repel. Observations and assumptions. First, we observe that both tapes repel because they contain the same sign charge. The top tape floats 0.022 meters when the other tape moves towards it. The electric force due to the bottom tape opposes gravity. The assumptions we came up with are that the charges are distributed evenly amongst both pieces of tape, and the tapes have the same value of charge. Our measurements of data are reused from Lab 1. The computational code, however, is changed. You can find this code in the description of this video. The lines of the code include a function for the electric field, and then a function for creating the tapes, and then the arrow scale for the electric field vector arrows. Once those are created, you can move on to create the net electric force on the top tape initialized at 0, an arrow scale for electric force arrow, and then an arrow scale for the gravity force arrow. Moving forward, you must create a code to iterate through each piece of tape on top tape, and then initialize the net electric field at the top tape. After that, you must iterate through each piece of charge at the bottom tape. Then calculate the electric field at the location of the top tape due to the bottom tape. After that, calculate the electric force on the top tape due to the bottom tape. Then once that is done, you can create the arrow for the net electric field at the top tape due to the bottom tape. Once the code is complete and ran through, you should result in a computational model similar to this. This can vary between the charge that you created that you got from the previous lab. When the code is ran, we get the results of the estimated net charge on one tape, the magnitude of the electric force due to previous charge, the magnitude of gravitational force, the new electric field, the tape charge with distributed charge, and then it's complete. So in conclusion, we have our what ifs and why statements. The what if statement is, in the previous lab, you modeled the same tapes as single point charges. Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with the line charge model. So from lab 1, the charge was -1 times 10 to the 8 coulombs, and from lab 2, our charge was -5 times 10 to the 8th coulombs. This charge resulted in a 419% change when you use the equation of the new charge subtracted from the old charge divided by the old charge multiplied by 100 to get this percentage. So our why statement is the two computational models for Q, points charge model versus line charge model, will be different. Why are they different? Which value is more likely to be closer to the real value, and why? The line charge computational model for the tapes is more accurate to the real value. In other words, this lab, lab 2. It considers the distance between every charge instead of 2-point charges, unlike lab 1.